First of all, we'll start with a couple introductions. The two speakers will be myself and Kaylee. Um, so for those of you who don't know me, I think I know everyone on the call right now, but for those of you who don't, my name is Josh. I'm the CEO of Advanced Ag. We've been working with biologicals a very long time, and today I want to kind of go through our journey and talk about some of the newer updates that we've been working um, on our technology. So yeah, Kaylee, maybe you want to introduce yourself as well. Kaylee will be speaking a little bit today on some of the grant funding opportunities that are out there for producers.
Hi, I'm Kaylee. I'm Director of Sales for Advanced Ag. I'm Josh's wife, so part of the family-owned business. Sorry I was late getting to this. I was just on a call with another grower that's in Saskatchewan and can't figure out Zoom. So I'm sorry if anyone had any issues logging on this morning, but we'll try to figure out an easier way to do it moving forward. I'll be talking about the funding, as Josh said, later on in the presentation, just kind of going through what options are available to growers to help with that barrier to entry with trying sustainable technologies. And anything else that you guys need, you can just reach out through the chat. I think Josh probably already mentioned that, but if you have any questions throughout the presentation, just pop them in there.
Thanks, Kaylee. I personally can't see the chat, so with my screen being shared, can everyone see this okay though? Just want to make sure.
Yep.
Okay, perfect. Thank you. So yeah, I can't see the chat here. So if something comes up, maybe Tanner or Kaylee just stop me and we'll address those questions as we go along. So yeah, as mentioned, I just want to touch on a little bit about biologicals in general in the industry. There's a lot of excitement around these products, but I want to talk about our journey as a company being involved with this type of technology for the last 24 years. We really have been a part of the past, the present, and we believe we're going to be a huge part of the future as these technologies move along in the industry. So kind of want to paint a picture of the journey and how we believe it's going to go. So just a bit of an overview of the topics we'll cover: our history, the growth of biologicals in ag, why are we seeing this in agriculture, the interest around these technologies grow so much, what are the issues with growth? Just like anything that's new in any industry, there are issues with growth, especially around something that's not as widely understood as some of the other technologies in ag that have been around forever. And then just, again, going through our history, the early research, the biopesticide research that we've been working on since 2017, return on investment on the farm. You'll hear this narrative over and over again throughout the meeting that sustainability and profitability have to go hand in hand. These products, as cool as they are and as great things as they can achieve, if they're not earning money for the farmer, then there's no value in that. So, and then Kaylee's gonna, as mentioned, talk about some funding opportunities. We just submitted $4.5 million of grant applications this month, and there's more that are out there. So really important for us to touch on that. And then I want to talk about the future of biologicals. I want to talk about biology and chemistry and how important those two are together and some of the research we're doing on that front, as well as some new research projects we have on the go this year. And then we're going to hear from Matt McKinnon, assuming he's able to get on this call at some point in time. He's been working with a lot of farmers in southern Saskatchewan. He's been really paying attention to the industry and what biological products are out there, and just kind of get his perspective as an agronomist in the industry. So again, I urge everyone to ask questions as we go along, and we'll turn this into an interactive thing with it being a smaller group. Okay, so yeah, as mentioned, 24 years we've been working with bacteria and different microbes. With what started as water and wastewater treatment, we were using bacteria to cycle nutrients in aquatic ecosystems. And back then there wasn't a huge market for these types of products. We didn't have customers flowing in by the day, but we had research money and grant opportunities to work with the Lethbridge College, now the Lethbridge Polytechnic, and the Aquaculture Center of Excellence to look at what these bacteria are capable of in aquatic ecosystems. Okay, so why are we seeing this growth in the ag industry with biologicals? Well, I just have a couple statistics here that I want to show. As you look at fertilizer use in North America, obviously there's been more and more of it applied per hectare, per acre, and that's helped us feed the world. One of the more important innovations in mankind has been fertilizer. Some of the issues, though, that we've seen over time is the efficiency of these fertilizers is definitely plateaued. And if you look at it, I mean, the cost on some of these products, just the detriment that we're seeing environmentally being leached into our groundwater and surface water. There's an issue here where the efficiency of these products, and this graphic here is just nitrogen, not very efficient. And as mentioned, just the cost. I mean, it's obviously since COVID, things have kind of gone crazy, but it's very unstable, and we're seeing a lot of this, not just in North America, but globally. Okay, so let's back up to 2017. That's not too long ago, but these were the companies in 2017 that were highlighted as the biological big players in ag that were being highlighted, and we're working on some interesting technologies with biologicals. Now, that's a pretty big list, but if you fast forward to 2023, that list has gotten a lot larger, to the point where there's a lot of crowding in a number of different spaces. So this list is kind of nice because I just pulled this off of Google, but this was 2023, and it's broken up into the different types of biologicals, your biopesticides, your stimulants, inoculants, biofertilizers. But you can just see how that how the industry has grown. More companies are working on this. So a lot of companies have popped up out of nowhere. And again, this is 2023. Believe it or not, we're not even on this list. So I don't know if these are companies backed by VC. I don't know. I have all the details with this list, but that there's more out there. So knowing that, seeing the growth in the industry with those particular companies, very interesting. But what's even more interesting and compelling is that from now, basically until 2029, we're going to see that double. Whether it's the same companies, it could be less companies in the space, but we're going to see this market double at the very least by 2029. We know these products are here to stay. And we're seeing some things that are backing this up in terms of strategic partnerships happening globally. We're seeing billions of dollars go into research. Indigo Ag raised $250 million. Pivot Bio raised $618 million. And we're seeing more and more of this. Just a lot of money going into this space. Not only that, you're starting to see in certain countries and continents like Europe, where legislative support and policy is really backing not only these types of products, but also limiting certain quote unquote conventional products like fertilizers, like pesticides. And so a lot of the companies out there are moving into this space to fill that void. And then, of course, we're seeing farmers use these products. Not only ours, obviously, we've seen our market grow quite a bit here in Canada and parts of North America, but we're seeing this all over the world. And I say mostly US and Europe, but the fact is, like, if you go to Brazil, almost all the farmers there are using a biological. So it's different per country, but we're starting to see a lot of adoption by these farmers and a lot of results on the farm. One of the things that's really important to cover off is the types of biologicals. For whatever reason, we all get thrown into the same bucket. you know, I can't even tell you how many times I've talked to growers or even agronomists, you know, highly educated individuals in the ag industry, and they say, well, I've tried something like that, or I've tried this type of technology. I've tried a biological. There's clear differences between the types of biologicals, whether it's a stimulant, those are your humic, your fulvic acids, your microalgae, your fungi-based products that are there to stimulate bacteria that are already existing in the soil. And then you have your, I should switch the order of this, your biofertilizers. Those are ones that were created not too long ago and were studied in many university research projects that were literally living organisms that can make nutrients more available in the soil, whether that's solubilizing phosphorus or making nitrogen more available to the plant. That, you know, our first product that we came out with in 2016, that's what it was a biofertilizer. And now we're seeing a lot of focus go into the biocontrol side of things, where we're seeing a lot of studies where microbes that can literally consume and prevent disease on plants. And we're doing some of this work as well. So really important to understand not only the categories of biologicals, but even within these categories. Like, let's just highlight humic acid for a second. We did a 2-year study on a wide range of humic acids, and even within that space, there is a huge spectrum of differences between these products. You have low pH, you have high pH, you have granular, you have liquid. And so it's really important to not only understand the different types of biologicals, but the differences even within these categories. Okay. So last year, something that was kind of neat is, you know, as we've grown our market presence here in Canada, we were highlighted as one of the top 12 ag tech startups for soil health in Canada through Thrive by SVG Ventures. And, you know, we kind of went into this accelerator, not with many expectations. We thought we would learn something, you know, rub shoulders with some people in the industry. Networking has always been, and building relationships has always been important to us in the business since day one. But we were exposed to kind of not only the Canadian ag industry, but the global ag industry. And we were able to meet with some, you know, large corporations and large companies in the ag space doing some cool things with biologicals. We did have the opportunity to go down to Silicon Valley, meet with Bayer and their R&D partnership and open innovation team. This was the most, at least, you know, the build up to this was the most exciting piece for us, at least for me. You know, the opportunity to go and listen to one of the head biologists talk about the research they're doing on biologicals. What was kind of staggering, you know, one of the first things they talked about in this meeting was that they had spent over $120 million on research just last year on biologicals. So, I mean, I wish we had that type of research budget here at our office because we can learn a lot. But as the presentation went along, one of the things that stood out to me was that, you know, some of the information they're sharing, we had figured out 4 or 5 years ago, and that there's a bit of an issue with how big the company is because they're trying to develop effective biological products, but they have a massive network. So any new product that Bayer Crop Science comes out with, they're instantly in 35 countries, hundreds of distributors, dealers, and these types of products aren't like your typical, you know, fertility chemical-based product where you put it on and you see the same thing over and over again. These are living organisms. We have to understand what the farm is doing, what they're trying to achieve. And so there's a bit of a distribution issue, in our opinion, with some of the larger companies until we figure out more consistently how these things are going to respond across different climates, different soil types, and just on different farms. Every farm is unique. So as we're seeing a lot of growth in this industry, as mentioned, there are issues with that. Just a fun survey that was done. I believe this is a US survey. So of 110 retailers or fertilizer producers, 89, almost 90% of those retailers are planning to increase their push on biological products. And that could be stimulants, it could be fertilizers, biocontrol. They just want to get into the biological game because the customers are asking. However, 41% of farmers in that same survey said that there was a lack of trust in these products. And it was a huge barrier to them adopting. So, us being involved in this space since 2016, we've had the opportunity to talk to a lot of farmers, ask them lots of questions. And I think there's some clear reason as to why there's a lack of trust. You fear what you don't know, number one. So a lack of education in this space is really a problem. So we're seeing that really across the industry. As mentioned, we've had people coming to us saying, what's the difference between your product and this product? I've tried a biological when really, nothing even close to what we're doing or what the next guy's doing. So for us, that education piece is really, really important. It's part of the reason we're having this today and have a lot of these grower meetings throughout the year is to really just educate. We are seeing a lot of technologies that are backed by venture capital money that it's really just a patent, process patent that is done where something in the laboratory was done. And it's exciting because we're seeing certain results on in controlled environments, greenhouses, but we need to see more than that. We need to see that is important. We need to see the scientific backing behind these products, but we also need to see the replicated work and the field data and what are the farmers saying, real life scenarios. And I feel like a lot of these products are missing that. I also have seen a situation where, we're always looking at other products that are out there globally, and we are seeing a lot of living organisms, biological products that are sacrificing product effectiveness for ease of use. So that we might have a product that says, put on 1 liter per acre or 1 ounce of liquid bacteria per acre, spray it on. I mean, mix it with water and spray it on. That's just not feasible. That's not going to work. So we're seeing a lot of that, which is creating some mistrust and some lack of consistency with trials. And then again, where's the data? It frustrates me more than anything walking through some of these trade shows and you see some nice, pretty pictures. Listen, we share those pictures as well. We have great lines in the field with certain trials that we've done, but there has to be data backing this and not just the farmer testimonial. What are the universities saying? What are the replicated trials saying? Not just the good plots. I have no problem with transparency and sharing 3 years of replicated plot work done with some of our research groups. If you're a producer, you need to ask for that data, not just what's on the website. Okay, 2015, we got into this space with biologicals for ag. I want to kind of just share some of the stuff we started working on. Actually, this work began a little bit earlier. We were looking at how we could mix a number of different species of bacteria that were going to have the right plant growth promotion functionalities built into it. We've all heard of compost teas. We've all heard of, guys on the farm bubbling up some stuff and just hoping to put some biology into their fields. That's great, but, it's really not hard to grow bacteria. They like heat, they like, food. And then, you combine that with water and the actual bacteria, and you can bubble up some numbers of bugs. But typically what happens is you have your lazy guys and you have your guys that have, a lot of plant growth promotion functionalities built into it. Let's call bacteria A here in this graph the lazy guys. They're the ones that grow fast. So you know, if you have a guy bubbling up some compost derivative, you're going to have a lot of bacteria A in that mix. And just like any species of any living organism, one wants to dominate. And it just so happens the ones that dominate are the lazy guys or the fast growers. Bacteria B, we'll call those the good guys. We'll call these ones the phosphorus solubilizing bacteria, the nitrogen fixers, the biocontrol bacteria, the ones that we really want. They get lost in the mix just after 5 hours. So imagine, you know, bubbling up bacteria for 72 hours. You might have a little bit of benefit, you know, targeted benefit, but you're going to have a lot of bacteria in that mix that really aren't doing much. So a lot of our focus in the early days was how do we get a lot of these bacteria B into the same mix, and have those numbers stable and high, the CFU high. And then from there, the functionality piece is really important. Just like anything, increasing numbers with biologicals is easy. I mentioned that. The numbers are important, but what they do and the functionalities built into the bacteria are, our scientists would argue are more important than the numbers. And people will get caught up on the CFU, but what are the bacteria doing? We put our bacteria through a series of different tests to ensure that the functionality is in the product. So if you look at this top left corner of your screen, we have a plate of tricalcium phosphate. That's the white area on this plate. By putting on a spore colony of bacillus, we're able to see that zone of clearing around that colony, which is orthophosphate. That bacteria is literally taking an unavailable form of phosphorus that we have in abundance in our soils and creating it to an available plant form. And that is something we do over and over again to ensure that there is phosphorus solubilization in our products. And it's not the only thing we do. We'll do nitrogen fixation, carbon fixation, to ensure, the functionalities, what we say the bacteria are going to do, that they are doing that. So this really, this whole thing with eggs started with some international stuff. We had guys going out there and spraying these crops, 10, 20 acres in size, high value crops, bananas, aloe vera, pineapples, tomatoes, in the greenhouse. But these guys were, didn't have access to a lot of the conventional fertility input products that we would have here in North America. And again, it being, small scale, manpower not being an issue, these guys were able to go out and spray the bacteria, the biofertilizer, numerous times, almost every single watering stage they were putting on the bacteria. So we were seeing really good results there. What does that mean for, Canada and North America and broadacre crops? We didn't know. We legitimately did not know. So we brought the technology up here in 2016. We started doing replicated trials with Dr. Bill Hammond, just outside of Nobleford, in southern Alberta. And, we just wanted to see if we would see any response. So I have a couple, data points here where we saw really good response on peas, on barley. We did 3 years of this, and we consistently saw yield increases on a variety of different crops. But, and I was kind of naive, back then thinking, if we see any response, any yield increase, every farmer is going to use this product. Well, this was manure spread land. It was under irrigation. We were using Alpine. Not every farmer uses Alpine. So at the very least, I think these trials were very important because we learned a lot about our products. We learned what crops would respond best. We saw really flat numbers with canola, and we didn't necessarily know why, but we completely stayed away from canola for the first 3 years due to the inconsistency we saw in that crop. We later found out that it was very likely due to the conventional seed treatment that was on the canola seed that was damaging or inhibiting our bacteria. We also learned what dosage rates would provide the best return on investment on irrigation, on dry land, on certain crops, what the best application method is. As good as a product is, biological product is, that's always important, but equally as important is how we're delivering it to the area it needs to go. So we found that putting it in furrow was much better than spraying it on, just because of the environmental conditions that can affect the bacteria. Bacteria don't move on their own. They don't have legs. They're not just going to travel around the soil. They need moisture to move. So of course, putting it in furrow was going to be better than spraying it on. We also found out that putting it through a pivot worked really nicely as well. It was getting to the root zone of where it needed to go. And then what soil types and what climates it would respond best on. So we learned a lot in those first 3 years, and more than anything that, the money we were spending was going somewhere important, and that these products do work. So it didn't take long for our farmers to try the products. We didn't always see a line in the field like this. We didn't always see consistent results in the first couple of years. We also didn't necessarily know why. But it seemed that every trial we did, there was better root development, there was better plant health, and that didn't always translate to ROI. It did not always translate to a higher yield increase. And that was something that we were focused on, just like everyone in the industry selling conventional, chemical inputs, put this on and you'll see a 5% increase or a 10% increase. We were trying to go that route in the early days, and it didn't always translate to that. And sometimes we would see a huge line in the field and you would think like, oh my goodness, this is going to be way more yield. Sometimes it wasn't. It could have been 5%, but it looked like 20%. Our first wow moment, though, for me, I always share this picture because we had 2 inches of rain with this Hutterite colony. I mean, not really a good crop on either side. This was a lentil crop in foremost. And just to stand on that line to see what we did with this particular trial, for me, was an amazing experience. Obviously, knowing that we're onto something, we still had a lot of questions that needed to be asked, and didn't have all the answers, but just to see something like this. And we would see, advanced staging. This was a crop up in Vegreville, where the crop on the left side, was 7 days advanced to the crop on the right. So just being able to harvest earlier for this particular farmer really meant a lot. And again, pretty pictures are awesome, but we need more data from our farmers. We need to understand, the why. Why were we seeing these lines in the field? So that was great. That was with a biofertilizer product. Talking about the solubilizing of phosphorus, the nitrogen fixation. We were seeing these responses, and then in 2017, we started looking at what these bacteria are capable of on disease control. So this began on a study with bananas in the Dominican Republic. We knew that in Florida, commercial banana production was essentially wiped out due to a form of fusarium called black sigatoka. And that in the banana industry, their disease is one of the biggest issues. And so we looked at, okay, what if we could develop a blend of bacteria that could consume the chitin layer, which you see here is the purple on this cross-sectional image of a fungal infection. What if bacteria could consume chitin? Technically that fungal cell wall would break down and would not be able to continue to grow. So chitin is a natural ingredient in our environment. It's one of the ingredients in crab shells, lobster shells, beetles, things of that nature. And so what we thought we would do is we would take some bacillus bacteria, we would grow the bacteria using crab and lobster shells as a nutrient source to feed them. And then we would starve that bacteria of the nutrient source before applying the product. And, the theory was it would break down that layer of chitin, the fungal cell wall, the fungal cell could not persist, it would die off, and it wouldn't create more issues. What was kind of staggering in this particular study was not only did the the biological product performed just as well, if not better, than the conventional fungicide, the bounce back rate, or the scientific term for that, the evolutionary development of the disease, was much lower with the bacteria product. And we see this in conventional agriculture with all of our customers, you know, whether it's lentil or chickpea growers in Saskatchewan or potato growers here in Southern Alberta. It seems like a lot of these fungicide applications are almost just a band-aid. It's, hey, let's deal with the issue that we're seeing, but we see it every year, and sometimes it's worse every year, and there's more and more disease. Some diseases that are you know, we've never seen before. So really intriguing data in this particular study, seeing that, hey, like using this as a way to deal with disease might be able to completely eradicate that disease. So that was great. We partnered with a world-renowned research group called Eurofins to not only look at, okay, these bacteria can deal with disease, but what can they do if we were to, in the same product, put a phos-solubilizing bacteria in there as well? So we did a ton of research on soybeans, and don't ask me why, but we have more research on soybeans than probably any crop, even though we don't do a lot of work with soybeans up here in Western Canada. I know Manitoba does a lot, but as you move into the States, it's quite big. So we did consistently see a 5 to 15% yield increase on soybeans. So really interesting stuff. But of course, our growers who are using the biofertilizer product, they wanted to get their hands on this. And I honestly did not know how big of an issue disease really was in some of these crops in Southern Saskatchewan. So I had a farmer at Gull Lake call us and say, hey, I saw the banana study. I want to try this on my lentils and chickpeas. We will split some fields. We'll use a conventional fungicide program, the bacteria, and we'll just see if we can see something through our biomass maps. And honestly, we weren't sure. We weren't sure the dosage rates, how much we should put out there. I think this was at 4 to 6, maybe 6 gallons on chickpeas per acre. So we went pretty high on the dosage rates. But you know, for him to send the images, the reports, the data back with this was very, very intriguing. In fact, his agrologist was with Sask Pulse, and so there's been some interest there on continuing some research. And we all know that Saskatchewan and really Western Canada as a whole, it's a small, tight-knit ag industry. Guys talk, and you know, word spreads fast. So we started working with more farmers in Saskatchewan, and this really brought us to a point where we wanted to look at, okay, these products are responding, we're seeing results in the field, we're seeing results on disease, but how is this making the farmer money? And going back to what I said before, this is something that over the last couple of years we've really focused on. There's the feel-good aspect of these products. You hear the buzzwords all the time: regenerative ag, soil health, you know, that's sustainability. That's great. But it's overused. And as good as these products are making you feel, you know, you're leaving your farm in a better place for your kids, is it making you money? And if it's not, is sustainability really there at the end of the day? So we believe that there is no sustainability without profitability. It has to make the farm money, and not in 3 years or 5 years or 10 years. The first year you use these products, it needs to make you money. So that's really been our focus, which is a little different from what we were doing with Dr. Bill on the replicated trials, where if we just add our product on top of a full fertility program, is there a yield increase? We wanted to look at how can we move the needle in terms of full programs, different fertility input products, and remove some of the cost with some of these products. And so we've been able to work with a lot of farmers who have been quite innovative and have helped us, you know, gather some of this research data. One farm in particular in Southern Saskatchewan did 3 years of trials on 4,000 acres of lentils. They did some wheat trials, and this was really good research because this farm is a massive farm. You think 4,000 acres of trials, that's the size of most farms. But you know, these guys farm a lot of acres. And we didn't just look at, okay, let's add our products in on top of everything else they're doing, and just to see if we have a yield response. We tried different products. We tried mixing our products with a stimulant, a humic acid, a low salt fertilizer, a higher salt fertilizer, a granular, and over the 3 years, we learned a lot. And to the point where, you know, the yield increase, if you can figure out the right pieces for this puzzle, I mean, these guys are almost pulling off, you know, 7 bushels better than what they were before with the control. So really big there. We're now doing on this particular farm this year, we're doing 40,000 acres of lentils. Because it's taken some time to figure out the right pieces that go into this puzzle. So pretty excited about that. We've been working with a potato grower in the Taber area. And this image here is interesting. I'm glad we took the picture because this was a number of years ago. He got into this with our water products. He was treating a dugout and he said, you know, I've been doing a lot of research. I've read some university studies indicating that, you know, biologicals can really help with soil health. He said, I have a patch, an alkali patch that I've tried to grow potatoes in. I cannot grow potatoes in. And we didn't really know if the product would respond. He said, I want to try some. So we do realize that in alkali soils that phosphorus is tightly bound up and is not plant available. And we also knew that the research we were doing on phosphorus solubilization, 3 of the bacteria we were using were very efficient at, you know, making that more plant available. So I said, you know what, Jeremy, go dump on like 100 gallons an acre. Like just go out there. It was a small patch, just dump it on. And he did, and he grew a crop, which really got him down the road of thinking, hey, there's something here. You know, as time went on, we learned more. And it wasn't something that happened overnight. We're now in this with him 6 years. I believe this is year 7 with Jeremy. And it's taken time. It's taken, you know, the small alkali patch to then splitting fields with the pivot, you know, trials. And for him, when you ask him what his biggest eye-opening moment was, it was when his skid steer operator gave him a call and said, hey, Jeremy, you need to check this out. We have a line in our storage bin where potatoes are rotting and potatoes are not rotting, and it's a clear line. He's a chipper grower for Frito-Lay, so obviously, I mean, any potato grower, the storability is a big issue. That's when he knew, you know, going in and looking back at the records, that the line was really an ACF trial that he had been working on. So he knew he had to go full farm at that point in time with the biofertilizer. Then we started splitting fields with the product that can consume fungal infections. And this was 2 years ago. We split some fields, didn't notice much difference, which was a huge deal when going up against the conventional fungicide. These guys will go and apply, potato growers, depending on where they are and what they grow, will apply between 4 and 6 different applications of fungicide throughout a year. That is a lot, and that is a high costing input for these guys. So the fact that we didn't see a difference in year 1 was pretty amazing. And I remember the first year we did it, this was a couple of years ago, it was a drought year. So there wasn't high disease conditions. So we had to be aware of that as well. Last year, he went full farm, and I was nervous for it because I wasn't sure that he said, listen, I can order the fungicide if I need to, if we do see something. But we did have a high disease pressure climate last year in this area. So definitely a different year. In June, he sent me this image with no context whatsoever through a text message. And I called him. He must have been busy, didn't pick up the phone. I'm having a heart attack thinking, oh my goodness, the disease is taking over his potato crop. This does not look good. This is not what we want to see. finally called me back and said, Josh, I can't believe what I'm seeing. This is incredible. Yes, we did have some early blight on our potatoes. We sprayed the SRP product, and within 8 hours, it completely crisped up the disease. It stopped it in its tracks. So he grew, between him and some other customers that he was working with, between 3,000 and 4,000 acres of potatoes with no fungicide on them whatsoever. Pretty eye-opening. Frito-Lay was in his fields a few months ago. They were talking to him, you know, looking at his fertility program. Over the last 6 years, and this hasn't been something that we did in year one, but over the last 6 years, every year we've reduced his fertilizer by 5%. And you got to figure a lot of these potato growers are over fertilizing anyways. So it wasn't a huge risk in the first couple of years, but as we pushed the envelope, we realized that not only are we able to reduce the fertilizer inputs by 25%, we've now cut out fungicide completely. So his return on investment, and he does have other land that's being leased, people submitting records to him where you would have your more conventional program. He's saving $80 an acre on his potato fields and pulling off more with a higher quality. So again, this is something that wasn't year one. We were going to say, hey, reduce your fertility by 25%, cut out your fungicide. This has been a process that we've worked with him, you know, over time. And then just, yeah, for any of you on the call, if you want to listen to his full story, there's a YouTube video. If you just scan this QR code, again, it's on our YouTube channel, so you can check it out anytime. This particular case study is a little bit more extreme. This is in Sunburst, Montana. This is through a producer, rancher, ex-agronomist who's really been dealing with serious drought conditions for the last 6-7 years. He's only an hour south of us, and you know, even last week we got a bunch of rain. I'm always checking the weather app to see if he's getting the rain. He is not getting the rain, so it's amazing to see the difference between our climates just an hour apart from each other. Corey has quite a following because of how he markets himself, the stuff he's trying to do to build soil health, and really just putting himself out there on YouTube and talking about some of the issues on his farm. Obviously, one being his annual moisture. This is a chart, you know, from 2013 to 2021. You can see, you know, every year it seems to be like he's getting less and less water. At least it's trending that way. His field days when we go out there, it's pretty sad to see. Even the one, I think it was 2 years ago, you could literally see the sage burning up on the side of the road. So really got him down the road of thinking, you know, we're spending a lot on our crops for crop inputs, only to collect a insurance check at the end of the day. And so over time, and this again didn't happen in 1 year, he started cutting out certain inputs. And, you know, obviously doing this seems very drastic, and we wouldn't, you know, recommend that every farmer just go out and cut out all of this stuff. This was done over time, and this is, you know, this is something that he has been able to do while monitoring his nutrient levels in his soil and in his plant. But he's cut out $162 an acre on his farm, which, you know, if you're able to grow that same crop, as sad as that crop may be, that is a much more sustainable way, more profitable way of moving forward. And again, he is measuring his availability, his nutrient availability in the plant and in the soil. And not only are we able to keep the numbers the same using our products and some other things that he's doing, we're increasing the numbers over time. So we know we're going down the right road with him. He's spending, you know, just over half of what he was in the past, and has the same crops. So, you know, him marketing himself, him putting himself out there, sharing this data with us and other farmers. What's really cool about Corey is he'll get a bunch of guys into a room and they'll talk about all the trials they've done. And I know certain pockets in Western Canada, we do some of that, but there's a lot of strength in that in in Montana. And every time they sit around the boardroom, they're learning from each other. They're talking about things they tried. And I feel like, talking about the lack of education in the biological realm, they're all learning quicker because they're working together. So we've seen a lot of growth in the Montana area because of this. And again, this is a QR code. He spoke at our Grow Better conference last year. Okay, I'm going to pause for a second, and I think this is a really good segue into talking about funding opportunities. We're going to let Kaylee talk about this a little bit, because if you're a Jeremy, if you're a Corey, and you're looking at moving down this road of regenerative ag, saving, money on your farm by incorporating new technologies, there are funding grants available. And there's more and more available as time has gone on. So I'll just let Kaylee talk a little bit about this. And then we'll carry on with some of the newer developments in our business.
To Josh's point, we're always looking for ways to basically reduce barrier to entry for our growers. There's a lot of guys that come to us and they're like, hey, I've been looking at biologicals, but the cost has kind of deterred me, or I'm not set up to apply liquids, or there's a bunch of different factors there. So one of the ways we're trying to mitigate that is through looking into these grant opportunities, trying to find ways that we can get part of their biological technologies or even their regenerative practices covered through government funds. So the two in particular that Josh has on the slides, the Saskatchewan Fund is actually now closed. They open it annually though from March 1st, I believe, till April 15th. $15 million annually is allocated to that particular fund, and it is to help with farmers who are interested in regenerative or innovative sustainable technologies. So we actually applied or co-applied with a lot of our growers in Saskatchewan, and by the 15th, we were able to apply for almost 4.25 million in grant applications. So what comes of that, we're not sure, but at least that funding is available to farmers, and if some of our growers are able to access those funds, it could be a huge change for them on their farm. Ardar in particular is through Alberta. I believe that one has also now closed, but again, that's an ongoing fund that will keep reopening. They do, this one was the 2.0 version, so I'm sure they'll have a 2 or 3.0 version coming out next year. But again, it's just to help offset some of the costs associated with trying to increase soil health, plant health, and other types of things on the farm. So these are just ways that we're trying to help limit the barrier to entry for our growers, and it's mutually beneficial. We get research back from it. Proper trials are completed. There's a principal investigator on the project. So we're working with a reclamation company that's helping to facilitate all the research project part of it. So it's really beneficial to both parties, but that's basically all I have right now. We are looking into more funds. I keep seeing more and more come across my plate. So the more that are available, the more we will send out in a newsletter and educate everyone on it.
Awesome. Thanks, Kaylee. Yeah, and just to kind of go back to what I talked about earlier, where we saw a lot of this in Europe a number of years ago, and it started to trickle into North America. Anytime there is any change, in agriculture or anything, it's nice to see some government support, provincial, federal support to help, bridge that gap into that change. So yeah, more and more of this is coming available, and we're always on the lookout for more grant opportunities. So honestly, just stay in close contact with us, and if something comes up, you'll probably see it in a newsletter, and we're more than willing to help you with these applications to partner with us. So okay, I just want to go into some of the more exciting things that we're seeing with biologicals. Obviously, everything we've shared up to this point, we find very exciting, but I think we're on the road to some massive developments with biologicals. I keep saying that in the last, 24 months, we've learned more about these products and these technologies than we have in the first, 23 years of business. And a lot of it is obviously through our farmers, working with us. But from a technology standpoint, we're doing a lot of gene data mapping. I know it sounds really scientific, but the whole premise around this is if anyone's ever done ancestry.ca, where you spit in a tube and you send it away and you find out what part of the earth you're from, what relatives you have in different countries, what children you have that you didn't know you had. That is a very simple genetic test that can be done on humans. We have not been on Earth very long. When we think about, how long Earth has been around, we have been on it for a very short period of time. So our genetic map is not large at all. When you think about bacteria, they've been around since really the beginning of time. So when we look at their genetic makeup, their ancestry.ca, the map that we're getting with these particular products and individual species, we are learning a lot. So just a couple charts I want to show you before moving into some new stuff. These are 4 bacteria that we use in our very common bacteria we use in a lot of our products. And then we put a bunch of plant growth promotion items, functionalities on the side here, and then values associated with those functionalities. And I know if you're just seeing a bunch of numbers, but as you start to hone in on what these numbers mean, these are the ones that are directly related to drought tolerance. And very interesting, right? When we saw that 2 inches of rain on that Hutterite colony, why were we seeing this? Which bacteria was it that has that genetic makeup to deal with more stress and drought? Well, we know that, for example, if you look at heat shock proteins, these 4 are doing a pretty good job of that. Now, if in terms of biocontrol and disease resistance, these are the values. Look how high these values are of biocontrol. Absolutely amazing. So what that's going to be allow us to be able to do is to, learn from these bacteria how they've evolved since the existence of time to naturally deal with stress and plant growth promotion with plants. So if we could extract, let's say, a Rhodosunomonas palustris and say, this guy right here, as well as the Licheniformis, are excellent at disease resistance. We could then put those 2 particular bacteria into a product for disease control. And this is something, when we look at individual species, this is just the Rhodosunomonas palustris. We've broken down a chart of all the things it can do. Look at the biocontrol. The yellow is the biocontrol. Look at nitrogen fixation. 10% is nitrogen fixation. Those are really interesting, values, plant growth promotion, plant health values associated with this one bacteria. So just being able to learn what the individual species are capable of, I think is going to shed a lot of light on why we've seen certain results as time has gone on. So what we've done with this initial research and trying to get on more acres is to put this into a seed treatment product. We're taking some of the more important bacteria species, and we've had about 1.5 years, close to 2 years of studies on thousands of plants, multiple different crop types, where we are coating the seed with this particular product. Last year, we had a couple field trials, and we're excited about this because when I talked about the early days with Dr. Bill Hammond, how the different application methods were really important, the bacteria needs to go where it's going to thrive. And we know that on the seed, in and around the plant, is the best location for our bacteria. Not the bulk soil, not necessarily on top of the plant, but in that root zone, on that plant when it is a baby. That is the best place to put it. Last year we had a couple field trials. This one was quite staggering. There's an irrigated field of field peas, and we had a 15 bushel increase with the seed treatment product. I don't know if we've seen a line that's been this dramatic to date, and it being one of the 2 trials that we had out there for seed dressing, we're very excited about this. So we will have, oh man, dozens of field trials with this particular product out there this year on a variety of different crops, variety of different methods, climates, things of that nature, as well as a handful of replicated trials with Olds College, Lethbridge, and a number of other research groups with the seed treatment. So I'll get into that, but very excited about this development. Stay tuned with some of the data that's going to come out from some of these research projects. Okay, let's talk about chemistry and biology really quickly. We are getting towards the end of the presentation. This is some of the newer stuff that we're working on, and even for those who've been, part of a lot of these grower meetings or heard our spiel before, this is new. So pretty excited to share this. We talked about the farmers who have cut out all of this chemistry in their input program and have incorporated biology. We're seeing, some pretty neat things. We know that there needs to be a balance. We're not out here as a biological company saying we're against conventional practices. We are not. We realize that fertilizer, that herbicides, that fungicides, they have a place, but it's the overuse and the inefficiency of these products that have allowed the biological market to grow. So if we can create a balance here, what does that mean? So we've done a lot of work on this over the last 12 months, and I have some interesting data to share with you guys. Going back to this slide with the Rhodopseudomonas, thinking about how much of this genetic makeup or the genes in this bacteria species are directly related to atmospheric nitrogen fixation. That 10% doesn't seem like a lot, but when you get the numbers up of this bacteria, we know that it's going to fix nitrogen. However, we also know that, through a variety of different university studies, that natural nitrogen fixation is a thing that happens in every crop and every soil type. But when we're adding nitrogen, chemical nitrogen, conventional nitrogen to a crop, the bacteria become lazy and it inhibits their ability to fix nitrogen naturally. This is an issue. So we have the ability in our soils and through different products to fix nitrogen very efficiently. But when we're adding that nitrogen source in excess, the bacteria can't do it naturally. So we've partnered with Ohio State University to start looking at this and quantifying, okay, what's the amount of nitrogen? Where's the sweet spot of, we apply our bacteria and that efficiency is at its highest. So Ohio State's kind of renowned for its turf research, and we do have a lot of golf course clients, turf clients, and ultimately turf is the largest crop in North America for land size. So it's something that, with our retail division that we're working with quite a bit. We wanted to look at the, where's that balance between nitrogen and biology? So these graphs, I know it's kind of hard to understand what's going on, just seeing these lines and colors. But basically what you're seeing here is in the left side, we have 0 nitrogen. The red is our bacteria. And right now we're just looking at the quality of turf in this study. The blue is, okay, just wait. So the middle is 0.2 pounds of nitrogen and the far right is 0.5. You can see that when nitrogen is at 0.2, there's a lot more stability. When it's at 0.5, it kind of gets out of whack with the quality. And I have this full report that I have no problem sharing with people. It's very interesting. there's a number of these charts that not only show that, quality, the color, of the turf is much more stable when the nitrogen applied is lower. Obviously more than 50% lower than the 0.5. When the nitrogen gets higher, things get out of whack. But there's a number of charts in this study that show like a really uniform data set when the nitrogen is lower. Our product is responding much better and the turf is responding much better. So very interesting stuff. We're going to continue this research with Ohio State and then obviously move it into some other crops so that we can find out what that sweet spot is. You think about someone like Jeremy, who with the potato grower who's cut back his fertilizer use by 25%. It's taken time and trial and error to get to that point, but the fact that he can do that now and save all that money, that is a huge deal. His farm is much more efficient because he's cut back, but it's taken time. If we can start to figure out what that sweet spot is with our products on a variety of different crops, we can go in year one and say, hey, based off of our data, we know we can reduce it by X amount. With the seed treatment product, we get a lot of questions around, okay, I can't collect my insurance check if I don't have a conventionally treated seed. And obviously you think of a crop like canola, maybe there is a black market out there for naked canola seed, but it's very rare. So we get the question around, can your biological seed dressing go on a conventionally treated fungicide treated seed? And up until literally 2 or 3 days ago, the answer was no. We knew that over the years, we've tried compatibility stuff with herbicides, with fungicides. The bacteria by themselves, without protection, are wiped out on contact. They're dead. And even the bacillus bacteria, those are spore form bacteria. They're ones that are very resilient. You'll see them in a lot of products. Neil, I think you had a question on this, which we'll get to towards the end. They die. But what we've done with the seed treatment technology is kind of built in almost an encapsulation technology with the product, with a biofilm and a humectant, which it somewhat protects the bacillus spores on the seed, even though that fungicide is on the seed. So we looked at, it was Celeste, and it was another fungicide-based product from Syngenta, and how the bacteria would survive over 5 days. So we put it on the seed, and then measured the colony formation units day 1 and day 5, and nothing changed. The bacteria survived. So this is a huge deal for us, being able to give some of those plant growth promotion benefits to the plant, to the seed, while also looking at a conventionally treated seed. So just interesting. Obviously, this data is new. I have an entire scientific write-up on this that I'd be happy to send to anyone, how we did the experiment, the data associated with that. So very, very important to, development in our research. And then just talking about some of the newer research projects we're working on. We're getting towards the end here, guys. I know it kept you a long time. We are looking at clubroot. We're sending product to Inotech next week, where we are soaking the soil at different rates to see if we can deal with clubroot and even just move the needle a little bit with the clubroot spores in the soil. Very excited about this. Obviously this is a huge issue on brassica plants in northern Alberta. Again, if we can move the needle even a little bit, that is a huge deal. This will be happening in a controlled environment, at which point it will, if we show that we can reduce the spores even slightly, it will go to the field for further research. This one is probably our most expensive research project this year. We're doing some crop plots at Ag in Motion. We've never been to the show, but with all of the growth we're having in southern Saskatchewan, we figured it was important to showcase what we're doing. We're going to grow a lentil and wheat crop with no fungicide and a reduced fertilizer program. At the end of the day, just showcasing how much we're saving per acre on these plots. And we're partnering with AgQuest to get this research done. One of the ones that we're really excited about is with Matt Gosling and Mag Research out of Strathmore. We're partnering with 2020 Seed Labs to do some plot work with the seed treatment, but also to look at infected seed. So 2020 is going to infect a variety of different seed, whether it's wheat, I think they're doing some pulse stuff as well, with a variety of different diseases. And we're looking at a number of companies' products, seed treatment products, conventional and biological, to see how effective they are on infected seeds. So we are a part of that research project. I just signed off on that this morning prior to this meeting. And that is something that, is obviously, and what I'm excited about this is that the data is actually going to be public. We think the transparency is good. At the end of this study, everyone will be able to see the data from this report. We are doing a lot of this research in Germany right now, up against a conventional seed treatment, Celeste, which is through Syngenta, on winter wheat. We will have more data on this research in the next month or two, but just 14 days after planting, we did notice through plant growth promotion, better root development, uniform height and better coloring on the winter wheat with our particular product. So very excited about that. That is all I have. I do want to have a quick recap, and then I wanted Matt McKinnon to speak for a second as an industry professional and his experience, working with some of the growers we're working with in southern Saskatchewan, and just where he believes this world of biologicals is heading. So just before Matt talks, I just want to recap that we know biologicals are here to stay. We know that education is the missing piece. It seems like every day we're learning something here in the office. So I can imagine, the farmers and the lack of education that they have on these products. My biggest frustration in this industry is the claims being made. We have products out there that say they're biological, that they have bacteria in it. You look at the SDS, you look at their label, there's no bacteria in the product. So do your due diligence, look for the research, look for the data, and ask what farmers are saying. We're happy to pass along a number of different contacts for every farmer, for guys to talk. How's it worked for you? I can say anything we want to say, but talk to the guys using the product. And at the end of the day, we're just scratching the surface. The future is bright for what these products can mean for sustainability, for food production, and it's a very exciting time, obviously, for our business, but for ag in general. So I'll segue this into Matt, just talking a little bit about his role and his company Achieve and what he's been doing with some of the farmers in southern Saskatchewan. And then we'll get into answering some questions.
Well, thanks, Josh. So I won't be too long. Quick introduction. So we're an independent agronomy business based out of Etonia, Saskatchewan. Here we service not only Saskatchewan but Alberta. There's 6 of us currently on staff right now. So how we got involved, I guess, with Advanced Ag is just would have been last year, but previous to that, we were kind of going down the road of looking at regenerative products, other products that are in the market here. And what really hit home with us is one of our customers basically came to us, and I think Josh Cayley, have heard me say this a few times. What kind of kicked us off down this road is he was spending more, putting more down than what his grandfather or his dad was doing. So, and he wasn't gaining anything. He really wasn't getting anywhere, but he was spending more and doing more. So we started going down this road and looking at regenerative and looking at, well, maybe, and how Josh mentioned there, ROI, how can we trim a little bit of cost out of here without sacrificing or potentially growing or gaining in yield? So That's kind of where we really started, and since then we've been working more with Advanced Ag because Josh did hit the nail on the head there. There's so many products out there, I guess, in regenerative, or want to say that they're biological, which have you. But the biggest thing, I guess, for us working with Advanced Ag is how transparent everything is. We've worked with other regenerative type products where they don't want to release the bad information or the trials or the results that did poorly. Where Advanced Ag is more than welcome to say, hey, this is what worked and this is what didn't, and how we're going to correct it. So it's exciting, and it's very transparent working with the Advanced Ag guys here, and we think going down the road here, we feel this is where the industry's going. You're seeing in our world, we're not tied to sales or anything like that in regards to product, but we have a lot of guys that over the years that have been drifting away from seed treatment, that have been drifting away from fungicide, this sort of thing. And we're not saying, hey, eliminate all these products altogether, but maybe we don't have to rely on them as much as we have in the past few years here, and even that in regards to fertility. At the end of the day, everyone on our staff here either farms or has farmed to some extent. And we all know what it costs to put a crop in and take a crop off. And the biggest thing is the ROI. It's the money in your bank account. And in Etony here in the greater area, we've been suffering going through a drought here for about 7 years now, roughly. Hopefully this year we break that and we can put together a crop and not have to collect crop insurance. So again, it all kind of comes back to thinking outside the box here, and that's where we find, and we're excited to work with the Advanced Ag guys here. So yeah, a little bit of I guess about us and how we got involved. So
Thanks for that, Matt. No, yeah, and I guess, just to echo what Matt's saying, it is all about these relationships. It's about this transparency on what's working, what's not, and what he's saying is basically what we've heard too. I mean, that's where this all started. I remember the first customer we ever had was in Schuler, Alberta. Actually, this is his lentil crop on the right hand side here. And that was the first, I knew nothing about ag at that time, honestly did not. And that was the first thing he said. He's like, we got to change something. This does not work. We are spending more and more and more. We're not getting more. This is not sustainable. We have to. And so he kind of went down the rabbit hole of YouTube videos, university studies, learning about it, the Elaine Ingham, School of Soil Food Web, all that kind of stuff. And it's like, hey, there's something here. We don't have all the answers, but we need to kind of move in this direction. So, yeah, I mean, that's been the messaging we've heard for many, many years. And Matt, obviously you being an agronomist and recommending input programs for your farmers, it's definitely something, especially in the drought areas that seems to be, more magnified than anywhere else.
and that's where we find it's going to be a good fit. So, for example, we did some trials of SRP last year, and more guys in our area are finding chickpeas in the rotation here as it seems like the years go on. So, we really wanted to see where the old conventional way with chickpeas, which most guys know, is you got to be out there. There's no going to the lake. You're going to babysit that crop. You're in the sprayer cab every week. And we've been with a lot of research and trials and that sort of thing. We've been kind of drifting away from how much applications we're doing, fungicide applications we're doing to that crop. So we did a trial last year. We just wanted to see, and again, take it with a grain of salt. We are in a drought area. We I think we averaged maybe 3 inches or less of rain last year. But going back to that ROI, we applied a fungicide we had a check fungicide and then SRP. The SRP and the fungicide were basically neck and neck. They're basically within that margin of error. But the big difference was the cost per acre, that ROI. It was half the price of what we seen for that fungicide. So that's what, again, just thinking outside the box. We weren't sacrificing. We were basically on par, but it comes back to that ROI. And at the end of the day, everyone's farming. It's the cliche, you want to be there and look after the soil and all that. But at the end of the day, it's a business and you want your bank account to have a few more dollars in it than when you started. So
And what's interesting from our perspective, because we deal with farmers in southern Alberta, in northern Alberta, northern Saskatchewan, southern Saskatchewan, and as far east as New Brunswick, as far west as the Okanagan, and into Montana. So our spectrum of growers is quite you know, there's a lot of differences between these guys. Where we are seeing more of our growth as a business is where guys almost are, I don't want to say backed into a corner, but it's almost like they're forced into change, right? Like it's like the conditions, 7 years of drought. Like if we don't change something here, it's not looking good. You can only take so many years of that. And you would think that like with the results we've seen on this potato grower trial over the years, you would think every potato grower, I mean, there's real data here. We have agronomy reports, like real data here and ROI data suggesting that, hey, we could do this on every potato acre. But guess what? Those guys aren't as eager to change because they still are very, very profitable. That change is not going to come from the farmer in that industry, in my opinion. And I don't want to bunch them all together, but it's going to come from the processors. It's going to come from the industry saying, hey, we want our products more sustainably grown. McCain's and Cavendish and Frito-Lay want to put that regeneratively grown on the bag of potato chips. And that's where things are going. So I just find it interesting to see where our growth as a business is happening. And it's in the extremely stressful growing condition, you know, areas and mostly drought areas where guys are saying, hey, like, we don't have the benefit of a great rain every single year where we're profiting so much per acre. We need to, if I can use something that's a little cheaper than a fungicide and it does the same thing, that's a huge win for me. Every dollar counts on the farm. So that's where things are going. And so again, for our focus, Southern Saskatchewan has been a big one. And then obviously Montana and a variety of other areas, but just interesting from our perspective, you know, you'd think we've done every potato acre and there is a lot of interest because I think guys realize that you don't want to be like the last guy to be a part of this, right? Like they know it's coming. And so there's interest, but there's not that like instant desire to like change right now. Like we're forced into that. So just want to make a comment there and I can stop sharing my screen and I think we can get into a couple of questions. So, Neil's got one on other market bacillus, yeah, trichoderma, yeah. So the bacillus product, you'll see it in everything. In fact, you know, a Bacillus subtilis is probably in every single product. It's easy to produce. It's in fact at Costco. Have you seen those Cove drinks? The Cove drinks, they're like a no sugar. They say it's probiotic type drink that you have. There's Bacillus subtilis in that drink, so it's good for your gut health as well. The thing that I would highlight with products that have similar bacteria, if not the exact same bacteria species that we have, is that functionality piece that we're doing these exercises and training these bacteria over thousands of tests to make sure that they are the best ones to solubilize phosphorus, to fix nitrogen. The analogy I use is if there was a bodybuilder here on this, you know, on this call right now, that guy's training every single day to do something that I am not. I do go to the gym, but not as extensively as some guy who's taking supplements and who's lifting every day and, you know, can outlift me. We are building in those functionalities with the bacteria species probably a lot more efficiently than a lot of products out there. But again, I urge people to try things like, you know, what we found even with humic products, like we technically probably should be selling some of these humic products because we've seen a response with a stimulant with ours. I just think human nature is we want that one answer. We want that one product that's going to do all these things. And what we're finding is that's really not the case. We have a great product. There's a number of other great products out there that chances are they, you know, promote each other, you know, they work well together. And so, you know, the trichoderma thing's interesting to me because I have a blog on our website about how difficult it is to manufacture fungi-based products and apply them to the soil. And unless you're doing it constantly, which really isn't feasible for broadacre farming, it's difficult to have a commercialized product that way. You have to understand, you know, going back to the soil food web, bacteria are at the very start of that soil food web, and then it's fungi, and then it's protozoa, and all these other things. If you are increasing the beneficial bacteria at the very start of the soil food web, you're going to have the natural interactions with the fungi, and everything down the road is going to be promoted as well. So we've done a lot of work on this. Of course, we're always paying attention to the competitors. There are a few out there that I do think are legitimate, that are pretty solid, and most of them, like Syngenta's got a good one. It's actually very similar to our seed treatment product. I think because we're smaller, we'll be able to keep the cost down for a lot longer than they will, but we'll see, right? That's why we're putting it up against theirs. We want to see, you know, how ours shakes up against some of the big guys. So yeah, I think it's just paying attention to what's out there. Everyone's got a bacillus. Our seed treatment is exclusively bacillus spores. I think there's 3 or 4 different bacteria in that one. The SRP is all bacillus, just very resilient bacteria that commercially are easy to use. We do have some bacteria that would be facultative, which means that they're aerobic and anaerobic, and they can move between. Those are very finicky, and I can tell you right now that there is no commercial ag products that are using those bacteria just because of how difficult they are to use. But if you Google Rhodopseudomonas palustris, which I think Google could correct your spelling on it if you typed it in, but Google that, and the studies done with that particular bacteria species, it might be one of the most amazing bacteria species known to man. It is incredible at remediating soil, at waste. They've done studies on oil. Like, it is an incredible bacteria species for fixing carbon, for fixing nitrogen, for controlling disease. Yeah, do your research. And I think I just urge every grower, every person in the industry to do that work. Look at the products. Ask for the label, ask for the research, go on Google. I mean, we have so much information at our fingertips now that we should be able to look into these products further and figure out the differences. And, you know, I think at this point in time, at least here in Canada, we're very aware of our quote unquote, I don't want to call them competitors because they're really doing completely different things than us, but ask us about them. You know, we do a lot of work with these products, and we know a lot about, you know, other products that are out there. So just ask us and ask other growers. Looks like unbrewed ACFSR is the longest shelf life that has been tested on each of the 2 products. Unbrewed in regard to, brewed. Brewed, that has come a long way. So the SR, I didn't even get into this with the research stuff, but when you're brewing ACFSR, that's the biofertilizer. There's 3 components to that brew that are really important for plant growth promotion. Enzyme production, which helps break down complex compounds in the soil and makes them more nutrient available. Biofertilization, which is like nitrogen fixation, carbon fixation, and then hormone production. So the reason it's a 72-hour brew right now is that all 3 of those are kind of at their peak over 72 hours. What we didn't realize is how important that hormone production really is. Hormones aren't living, but when the bacteria are brewing and producing, Stoller Products does a lot of work with hormone-based technology. Things like auxins, gibberellins, cytokinins, those are really, really important for plant growth promotion, for plant stress, and the SR has that built into it. So as we've learned about the profile of these hormones, the shelf life of the SR has extended significantly. We went from 2 years ago having a 14-day shelf life with ACFSR once it's brewed. And during seeding time, that can be an absolute pain in the ass to deal with. It's now at 90 days. So once it's brewed, it's good for 90 days. The SRP is not. It is only good for 14 days once it is brewed. However, we are working on some research and technology to get this into a form where it does not have to be brewed. We are very far along this process right now. And the issue is commercializing it. So we do need to see some more data in the greenhouse and replicated stuff with this particular product, which we are working on this year. And then we need to probably acquire around $1 million US of equipment to commercialize this product. So it is actually very far along, and we do believe it will be a powdered product that can be added to a tank, almost, probably mixed with a lot of other products, and will be very effective as a biological biocontrol product. So more to come on that. We're continuing to sink a lot of money into research and development to make these products easier to use. Those are good questions, Neil. Thank you. I appreciate everyone hopping on. And thanks again, Matt, for helping us out with this and giving us your perspective on everything. Thank you.
Awesome. Thanks, guys.
Thanks. All right. We'll see you. Bye-bye.